I started the whole thing muted. I'm just off my game this morning. Hello, welcome to Enlightning. Let's do that again. My name is Whitney Lee. I'm a developer advocate at VMware Tanzu, and I'm here with Michelle, who's going to teach us about Pixie. Michelle, will you introduce yourself, please?
Yeah, hi everyone. It's nice to meet you all. I'm Michelle and I am a maintainer of the Pixie project, which I've been working on since 2018 now at this point. So super excited to be able to talk to you guys about Pixie and just how it works.
Oh, I'm so excited. This is so I've been doing a series of enlightening shows about observability, and I'm hoping to learn about every single observability tool in the CNCF. So that's why I knocked on your door. But with other things I've talked about so far, I had some idea. Like I knew FluentBit does logging, I knew Jaeger does traces, but Pixie, this is all I really don't know what's coming today, and that's very exciting. So well, first let's say hi to Epic Tralala who's here. Thanks for being here, friend. And then let's jump right into it. Can you paint me a picture, please, of what the world was like what problems were happening that caused Pixie to get created?
Yeah, of course. So Pixie was kind of created around the time when microservices started getting really big. And, before
Okay.
microservices, people had monolithic applications and, you know, you would go in, you would instrument your applications, you add a bunch of logging to kind of figure out what's going on. And things don't really scale when
Uh-huh.
you start having a bunch of microservices because you get confused. Like, how do these services, like, how does this service talk to this service? Which service is this one talking to? And there's just a whole bunch of information that you need
Yeah.
to gather to get some insight into how your application is running. And a lot of the times, like you
Uh-huh.
probably hear from a lot of developers, it's like, oh, I forgot to go and instrument this part of my code, and something happened, and now I don't really have any visibility into what's going on. You go in, you add your logging or you add your instrumentation, and you have to redeploy and kind of start that whole process over. You wait for the issue to happen again in prod. But it's always just a long process of just like making sure you go in, add in the right pieces, to have all the data that you need to make the informed decisions when something happens. And you also hear from a lot of people, especially in a lot of bigger organizations, they want people to use open telemetry, for example, to instrument their applications. There's usually some set of boilerplate that people need to be able to set up to start building their applications to make sure all of those, like, uh, all the metrics that they need is covered. And that doesn't always happen in larger teams. Like, one team does something differently than the other one. And so it's like there's always gaps in your data. And so what Pixie is designed to do is to give you instant baseline visibility into
What
how your application is running without needing to do any instrumentation at all.
so what I'm hearing about the problem is that understanding distributed microservices, it's extremely complex. So it's hard to do, period. And then it's also very tedious to actually implement. Are
Yes,
those
that
the
is right.
two big problems? Did I hear you
Mhm.
correctly? Okay. And so it's hard and then it's tedious. Tedious. Yeah. Just even, and that's based on my very limited experience by talking to different projects and different folks about observability. We're worrying about different signals and then worrying about instrumenting applications for each signal and then also instrumenting like how are we going to do that for the infrastructure, and just
Right.
there's a lot to consider, and I get this a lot. So Pixie, now we're to Pixie. So well, I want to say hi to Ghana Tech. You've been on the last few streams. I appreciate you. Thank you for coming. um so Pixie aims to solve this, but what is Pixie exactly?
So Pixie is essentially a way to, it automatically collects all of that data for you and then provides an interface to query that
Uh-huh.
and visualize it so you can understand what's going on in your application. And it's always kind of hard to pinpoint exactly like all the use cases that Pixie can help solve for you just because it collects so much data. And so you can really
Uh-huh.
to exactly what you're specifically looking for. Like I think some of the use cases for Pixie is like you can do network monitoring, infrastructure monitoring. You can get things like application profiles, so you can really dive deep into like your specific like application and code to be like, oh, this function seems to be taking a really long time. So there's just like so much data that Pixie collects. So it's always kind of hard to be like, oh yes, this is the exact thing you can do with Pixie when it's just so versatile.
Yeah. So Pixie is an observability tool. Can we start there?
Yeah, of course. So Pixie is an
Or is
observability tool to basically collect
okay.
a bunch of information about your application without needing to do any instrumentation.
Oh. To help uh, that helps you collect lots of information about your application without any instrumentation. Is
Yes.
that correct?
Yes.
This is fascinating. So, oh, I have questions. Well, let's leave it up to you. Where would you take it from here? I'm interested in like what is lots of information, I think is the biggest question that's coming to mind.
Yeah, I can definitely dive into, some of the specifics about what Pixie collects. So there's a lot of the standard metrics that you'll want, such as resource metrics. So things like CPU, memory, IO for the different pods in your Kubernetes cluster, or like network metrics, like you want to know like how many bytes have been transmitted or received on the network, or things like TCP drops, for example. So a lot of standard information that you can collect just by reading the process stats of the machine that's running the pod. Where Pixie really shines is that it does protocol tracing. So basically, we hook into the different like network traffic that's occurring on your cluster, and so we're able to read full body messages just between the pods in your application. So if you're sending an HTTP request from one
Ah,
pod to another, we're actually able to hook into that and tell you like, hey, this request was made at this time. This was the latency for it. Here you can actually see the full like request and response body. And so you can really get deep into your debugging depending on what you're trying to do. And so we do that for a bunch of protocols. So HTTP is a standard example, but we also do it for like Postgres or like MySQL calls. So you can be like, oh, I made these queries to this database. And, whenever it was this particular query matching like, this schema, it was always really slow or something like that.
so by lots of information, it seems to fall under two umbrellas. One is like related to resource usage. Is that correct?
Yes. So like
Before you
resource
brought up,
metrics,
yeah.
network metrics. Yeah.
Okay. Resource metrics and then network metrics. And then what you're describing sounds like tracing, but is it tracing
So it's not,
in terms of,
so it's
yeah.
protocol tracing, but I think a lot of people get it confused with like distributed tracing, where, we're able to actually link a bunch of different, what is called, I think you've probably talked about it in previous shows, is just like spans versus traces themselves. And so spans are kind of, that
Uh-huh.
hop from one pod to another, but then you're able to pull that into a larger trace and say, oh, this pod talked to this, and then this pod talked to another one, and it's all kind of part of that same request. Pixie's not able to make that link for you to be like, oh, these HTTP calls between these pods were all part of the same request started by like, this function call or this request this user made, but it's able to get like the individual spans between pods and give you really rich information about those particular spans without, you having to go in and do anything.
I love it. So let's like a resource metric, what might be like CPU usage, yeah?
Yes, CPU usage,
I've
memory,
never,
IO.
okay. Okay, and then network metrics. What's an example of a network metric?
So a network metric would be like bytes like received or transmitted from this pod, or like number of TCP drops.
Okay, bytes received from a pod. And then for protocol tracing, let's first define what protocol tracing is, and then we'll give an example of it. Does that sound good?
Sure.
And then let me say hi. We have some new folks here saying hi in chat. Hi, Rosie Reddy. Thanks for being here. And hello, Mahendra. Thanks for coming. Okay. Okay, what is protocol tracing, please?
So protocol tracing is basically just tracing the messages between the pods in your application for a bunch of different protocols. So it hooks into, your network traffic. And so for particular messages that are being sent from one pod to another, we are able to trace that and give you more information about what that request looks like, from, data such as latency to what the contents of the actual request are.
Cool. And then what are the protocols that you support?
So we support a bunch. So some that I can think of off of my head are, HTTP, HTTPS, database calls such as Postgres, MySQL, or Redis. We support things like, tracing your Kafka messages. So you really understand just like, who's making these requests to Kafka, which is the clients that are putting messages on this queue, for example.
Cool. And then what's a concrete example of a protocol that might get traced? Yeah, what's a concrete example?
So I guess an example could be, your pod is trying to make a REST call to another pod. So we'll be able to read that and be like, oh, okay, so this pod tried to hit, let's say you have a retail application, for example, and somebody just added an item in their shopping cart. So it might be like, oh, this request was just made to, carts / add or whatever, or create item or something like that. And then you can actually go ahead and see the full request body. So you might be able to be like, oh, this person added socks into the cart, and this was how long it took, and here was the response that I sent back, which was just, maybe probably like a status okay 200 or something.
This is fascinating, because it feels like, and maybe I'm wrong, but it feels like a whole nother way to do observability than what I've learned about so far. Is it true?
I mean, I think that's like a very broad statement, but I mean, it's definitely something that, at least at the time that we started building out Pixie, it was just like mind blowing to everybody, where they're like, whoa, you can collect all this information and it really helps you dive deep into what you need to like figure out in your application specifically.
Would you recommend, like, what do you see? Do you see people using Pixie in addition to more traditional application instrumentation, or instead of?
No, yeah. So we actually do say that, Pixie is best used in conjunction with another tool. I think Pixie can be super powerful because, like we said before, it kind of collects, your baseline visibility, like metrics and protocol traces that, we can figure out and start collecting automatically. But at the end of the day, a lot of the tools built for observability, like OpenTelemetry, for example, or Prometheus, they try to capture application level information that we can't really figure out for you. So, for example, it's like going back to that retail application. Pixie doesn't know it's a retail application. It might be able to tell you that, oh, this request is being made to this pod, for example, but if you wanted information like the average number of items that people usually put in their cart, Pixie's not going to help you with that because we just have no idea. So
Okay.
we do tell people that they should be using Pixie in conjunction with other tools where they can go ahead and instrument kind of the custom level metrics information that they might want. And so Pixie covers kind of, the baseline that, it's like you can go ahead, you don't have to think about, adding all these things that you you usually want to collect, like resource metrics. Pixie will do that for you. And then you just need to think about what you need on top of that.
So that answers my question. Thank you. And then in terms of a pod calling another pod to add an item into the cart, does Pixie also have the context of that entire network call? Well, I mean, that entire string of calls, then the response that it gets added. You're probably not doing your. Anyway, does it have the context of one request moving around different places, or is it just?
It's just that single request from that pod to another pod, which is called a span. We're not able to do distributed tracing, which is connecting, all those requests across a string of pods together. The reason for that is in order to do that, you do need to go in and kind of that's when instrumentation is needed, that you need to say, hey, this call from this pod to this other one, this is all part of the same request. And, the reason for that is because this pod needed to get this information from another service or whatever. So Pixie, what we try to do is we just observe. And so, all the information we're able to get is just from, hooking into, the network traffic and figuring that out. But a lot of this, kind of going back to what I said before, you need to have some custom knowledge of your application to do things like, distributed tracing, where you say, this request is linked to this other request or something. And so that's where other tools like OpenTelemetry really come in handy, where they allow you to instrument that information by, adding something to the headers where it's this is part of this request or this trace, so that you can actually hook them together. And if you do that with OpenTelemetry or some other tool, then Pixie can actually go ahead, because it can read those headers and be like, oh, these are part of the same request. But natively by itself, Pixie cannot do that.
Okay. So I want to kind of recap everything we talked about, so make sure we have the base knowledge that we're building on for the rest of the episode. So Pixie is an observability tool with which you collect a lot of information about your application, but without any instrumentation. So you don't have to instrument your apps, which can be a tedious thing to do. And by lots of information, we mean it can collect resource metrics like CPU, memory, or ins and outs. It can collect network metrics, and it can do protocol tracing. And I was unfamiliar with protocol tracing. So those are tracing the messages between pods for various protocols. And so that's the example you gave was a pod in a shopping scenario. A pod might call another pod to add an item to the cart, and Pixie would be able to see and record that call.
Yes.
Does that feel correct so far?
That is correct.
Okay.
I guess one more piece of data that Pixie does collect is application CPU profiles. So I don't know if you're familiar with flame graphs, if you've talked about that in a previous show or not, but basically Pixie can build up a profile, so a CPU profile for you of just for your application, where is it spending its time. So it's for this particular function, let's say you call it in a loop many times, or it's incredibly inefficient, then Pixie is able to pinpoint that for you.
So app CPU profiles. And so is this the behavior of the app over time? Is that accurate?
I guess I wouldn't say over time, but for a certain period of time. Let's say your application is just running a bunch of things, servicing a bunch of calls, and there's a bunch of functions that go ahead and are doing that for you. So it's able to tell you not the exact amount of time that's spent in each function, but kind of proportion wise, oh, okay, maybe 50% of the time your application is running this function. And so that kind of helps you figure out, well, maybe you expect it to be running that function 50% of the time, because that's the most common thing you expect to be happening. But it also helps people figure out, if they don't expect it to be running 50% of the time, then that's a potential area they might want to go in and see if there's something like inefficient that they need to optimize in there.
So app CPU profiles show you how apps spend their time.
Yes, yeah.
Okay, great. Okay, so I can see, so one idea, I have a couple of questions. One is like, okay, the user experience I'm interested in. Like I have a cluster, I don't have any observability. I've decided Pixie's where I want to start, what happens next. The other direction we can go in, or you can choose. The other question I had, oh, now I lost it. Oh, is how Pixie records the network traffic. Like what's the mechanism there? Is it hooking into the kernel? Is it eBPF based? Yeah.
Yeah. So I think we'll probably cover both. So we'll start with the first question, is just kind of the experience of Pixie. So yeah, you start with a cluster that has nothing on it, or maybe we hear from a bunch of people too, they already have, tons of things running their cluster, their application is running, maybe they have some instrumentation that they've, added already. But all you need to do is, we offer a CLI, you can deploy Pixie with a Helm chart. There's a bunch of different ways to just deploy Pixie to your Kubernetes cluster. But you just run that command, and then in less than 5 minutes, or probably even less than that, then Pixie's up and running and collecting all of the data from your cluster that we can get. So it's like what we try to say, it's like 0 to 1 observability. All you had to do was deploy Pixie.
Install Pixie in less than 5 minutes. And then you already have, oh, this is a short section. And then okay, then what? Do I have access to, Pixie does its thing, and now I have a dashboard?
Yeah, so we also offer a UI as part of Pixie. Some people we have a CLI too, and so you can definitely query your data from Pixie using the CLI, but we usually recommend people use our UI, and from there it's like we have a bunch of dashboards that people like in the community have contributed, or that we've added ourselves as part of the maintainer team, that give you a bunch of information that people like usually need to use, like, oh, here are all like the HTTP network calls that happened in the last 5 minutes, for example. So a bunch of dashboards that you can just go and select through and just browse through the data that Pixie collects. But at the end of the day, we expose our query language, which looks very similar to Python pandas, if you're familiar with that. But you can basically go and essentially write what looks like Python to transform the data that Pixie has. So we expose a bunch of tables that you can go in and start filtering out things that you might want, or grouping or aggregating data using this language to kind of build your own dashboards as well. So it's a mix of like, here are a set of standard dashboards that people have wanted in the past with Pixie data, but also you can go in and start building whatever else you want on top of that.
With a Python-like query language.
Yes.
And then you said there are several dashboards?
Yeah, we call them just scripts in Pixie, but there's a bunch that people have written, or we have written, that you have access to, and you just select through them and just see what they look like and see what data that you can get.
So the user experience, install Pixie in less than 5 minutes. Pixie starts collecting data, and then you can access the data via the CLI or via Pixie's dashboards. And that's that?
Yep, that is it.
Wonderful. That is totally accessible. And nothing changes about the behavior of my application, or like whatever's going on in my cluster, Pixie just like plugs right in.
Yes, cool. That is right.
I don't have to change my cluster in any way to prepare for Pixie.
No, yeah, you just deployed Pixie and it just works.
Cool. What is it, just what's common for people to do first?
What do you mean by that?
Like I installed Pixie, I have access to data. Now what?
Oh, okay.
What's a
Yeah.
good,
So people most
what do
commonly,
people
it's
look up?
like,
Yeah.
you need to explore what kind of data Pixie has. And so they pull up the UI and you just start going through all those dashboards and seeing what kind of data we collect. So it is very exploratory. Like people
Uh-huh.
need to build up an idea of just like, oh, wow, like Pixie's able to collect this. And like, oh, I have information about this now. So it's a lot of like exploring and then
Uh-huh.
figuring out what data is useful to you. And that's always different depending on the person and, what issue they're trying to figure out.
Yeah. Cool. All right, let's dig into how Pixie works, or hooking into the network traffic. The network, as you say.
Yes, so Pixie is eBPF based, and I think around the time that we were kind of building out Pixie, um, that was still technology that was pretty new or just not like widely used yet, and so a lot of people didn't really understand what it was. But now I think as we're kind of progressing and we're seeing a bunch of different tools that use eBPF pop up for different applications, not just like observability, but for like security reasons, for example, I think there's just a lot more people who understand what eBPF is and how it works. But I'm also happy to hop into just like a very quick overview about eBPF for those who may not know what it is yet.
Yeah, let's just a quick overview of eBPF base. What advantages does that give?
Yeah, so basically, eBPF is a Linux technology that allows you to hook into um, different, what is called like, you can insert different probes into the kernel. So it runs at the kernel level, and you can basically think of it. I think like one of my colleagues, his analogy that he always uses that really helps a lot of other developers understand what eBPF is that you can think of it um, like a breakpoint in a debugger. So, whenever you're trying to debug
Okay.
something in your code, you set a breakpoint at a particular function call. And then when you do that, you're able to, like, it stops all your application and it stops at that point, and you're able to go and observe the state of your application at the time that once that breakpoint is called. And so you're able to like go in and like inspect your variables and things like that. And eBPF, you can think of it very similarly to that, except it's running at the kernel level, and you can set a breakpoint at you can set your breakpoint at places like in your function as well, and those are called um, uprobes. So like user probes, and so that you can be like, oh, okay, in this particular function, uh, let's use like OpenSSL's like library, for example. You can hook into like the read call or something like that and be like, set a breakpoint here, or you can set it at functions like kernel syscalls and be like, set a breakpoint whenever this syscall is called. And so the difference with eBPF and the debugger is that in the debugger, everything just halts, and then the user goes in and you inspect whatever you want. But in this particular case, you can go and be like, whenever you hit that breakpoint, then go and collect information about what the state looks like at that time, and then move on. Just because since we're hooking at the kernel level, you don't want everything to suddenly stop. So it's more just like at this point, when read is called, for example, then stop, collect data, and then continue processing.
I love that. I like that way of thinking about eBPF, the breakpoints idea. So one thing I know about eBPF is that it allows you to inspect and manipulate kernel calls in a safe and performant way.
Yes.
So and I think that might be worth asking about Pixie, is like how does it affect the cluster's behavior in terms of performance or in terms of resource consumption for Pixie itself?
So with Pixie, what we like to say is that we don't use more than like 2% of overhead on your particular node when you're running Pixie. At the end of the day, you do take a small, like very small performance hit, because it's like, you do need to like at that breakpoint, go and do something like collect data, write that data out. But we try to do it, in eBPF as little as possible, only when, those calls are actually happening. And so when we've gone and just kind of monitored what that performance hit looks like, it is under 2% overhead. But, it really depends on your cluster as well. Like, let's say, if we are hooking into every single time a network call is made and your cluster has like millions of network calls per second or something, I mean, that is a crazy amount. But, we are going to be going and hitting that breakpoint every single time. And so it's like, you can think of it like that. It's like, yes, you can understand why there's, why that needs to happen and that it can slow down very slightly, but it's usually not too much, because we try to keep it like very short and we don't try to do too much in that time.
Cool. So is there anything else you want to say about it being eBPF based, about how it works?
I mean, I think that kind of covers how it works at a high level. I just wanted to pinpoint just how powerful hooking into your applications with eBPF can be. So, for example, something that always blows people's mind is that Pixie can collect your network traffic, and it can even pull out like the full requests and response bodies of your network traffic before they're encrypted. So everyone's always like, oh yeah, like things are great, everything is encrypted, I'm using SSL, TLS, and things like that. But Pixie is actually able to read that data. So it's like, we're collecting your network traffic, and we can actually collect things that you expect to be encrypted. So things like passwords or like social security numbers, we are actually able to pull that out, and you're able to view that full like response body or a request if somebody's sending in a request, for example. And so it's just like, it shows how powerful using eBPF is. And so that's just something I wanted to highlight, is just like eBPF is really great and you can do a lot with it. So yeah.
That is cool, but it makes me afraid. But also I know there are eBPF based like tools like that for hackers that but like that actually doesn't that makes me nervous that you could read all my passwords and my encrypted stuff. How does that make me, how do I feel safe?
Yeah, so I think that's a great way to lead into just some more of how Pixie works. But we've kind of recognized that problem that people are like, oh my God, you're collecting very sensitive data. Oh, I think also other caveat to note about eBPF is, because it's so powerful and it's collecting so much data, a lot of how a lot of observability tools works is that, the data you collect, it's getting sent to some centralized place where you can go and query it. But with the data that we're collecting with eBPF, it's just so much data, right? Like if we're hooking into every single network call and your application is very busy and we're collecting, the full request and response bodies, that's a lot of data. And sending that out to somewhere else for storage, that's going to be really expensive. It's going to take so much network egress and storage. And so the next thing about Pixie that comes into play is that we use edge computing. And so what that means is that we're kind of moving where that data is stored and how it's computed closer to the data source itself. So Pixie, we run our collector as a daemon set on your node. So there's basically a collector per node in your cluster. And this is what we call the PEM. It's the Pixie Edge module. And so that's the thing that's actually doing the data collection itself using eBPF, or it's scraping your process stats to get you metrics. But all of the data that it collects, it's all stored in memory on that pod.
Okay. Okay, first let's say Pixie collects a tremendous amount of data. And a quick question there. So presumably if Pixie works so quickly, the Pixie's making choices about what's getting collected, or just collecting literally everything?
It is collecting
And if I
literally
wanted to collect
everything that
less,
it can. There's some
Okay.
ways to configure Pixie to be like, I really don't care about this, so just don't collect it. Like maybe you don't care about your application CPU profiles, for example. So there are ways to basically turn things off, but by default, Pixie is going to collect everything for you.
Cool. So Pixie collects a tremendous amount of data. Although you can turn stuff off. You can choose to collect less. And then Pixie holds that data in memory on the node. Is that what you said earlier?
Yes, yeah, we have a data collector that's deployed as a daemon set, and that's the thing that's collecting the data, and then once it collects it, it just holds on to it in memory.
I just want to check in about how much board space I'm using and how much I have left and how much you want to say and whether we seem on track.
I think we're on track. Yeah, we're good.
Okay. Deployed as a daemon set, collects data, then holds it in memory. And then what happens?
Yeah, so I think the point to kind of highlight here is since it's all stored in memory, that means that we're not sending the sensitive data out somewhere else where it's persisted, where, you know, somebody's going to go, like some random developer who has access to that database can go in and read, you know, your passwords or your social security numbers. And it also makes sure that you're not spending tons of money sending that data out somewhere else.
Sensitive data is kept locally in-house. What's the right word?
Yeah, I would say locally in-house, in cluster, within your like
in cluster. I like that one.
Yeah.
Okay. And then, so it's held in memory, and is it from there that the dashboard's doing the visualization and the CLI stuff is happening, or does it? Okay. And then, do people ever want to put this? Well, I think I want to record that. Do people want this data to be persisted in a more permanent way?
Yeah, and so this is kind of where Pixie being used in conjunction with other tools comes into play. So we do say, because you're storing all of this in memory, obviously it's like if you wanted to keep that all in memory for a very, very long time, and let's say we're collecting so much data, you're going to have to allocate a ton of memory for that particular pod on your node. And so, you know, you can do that and it will retain it for however much time that you can keep it in memory. It really depends on, you know, how busy your application is. You know, if you have more network flowing through your cluster, then, you know, maybe 2 gigs allocated to this particular pod is going to keep just like, you know, the last hour of data or something like that. If you're if your cluster is very busy. So we do say that Pixie is more for real-time debugging. And usually for most cases, we've seen that Pixie works or is able to retain data for the last 24 hours. Obviously, it depends on, you know, how busy your cluster is or how much memory you want to allocate to your data collectors. But what we see people use Pixie for is, you know, they use it for real-time debugging for something that's happening at that moment, or they're also able to kind of, once you dig into Pixie and see what data you need and what you kind of want to keep, then we hook into other tools. So we use open telemetry as a way to send data to other tools for storage. So people are able to be like, oh, okay, I find this particular information really interesting, so I do want to send this out. And so they can basically use Pixie's plugin export to send data to any other tool that accepts open telemetry to store it if they want to. So it's like a very case by case, like whatever they might want. And, before they send it out, they can check and make sure it's like, oh, there's no sensitive data that I'm sending out.
I have a question, and that is, once it is persisted to a source, some other source, can I still use Pixie's tools to be able to look at it and interface with it?
So that is something we get asked about a lot. And so we do want to build into Pixie a way to kind of hook into these other stores so you can keep using Pixie's interface for that. But at the current moment, you can really only query the stuff like if it's still in memory in Pixie, then you can continue querying it. But if it's some data, that was collected a month ago or something like that, it's probably not stored in memory on that particular node anymore. And so, you're going to have to go to that other tool or other dashboarding tool in order to visualize it. But, hooking it back into Pixie and kind of using Pixie as that interface is something we've been hearing a lot, and something we'll hopefully be working on in the future.
Cool. Great. So for data and storage, Pixie collects a tremendous amount of data, and then it has a data collector to do this that's deployed as a daemon set. And then it collects all this data and holds it in memory, and then therefore sensitive data is kept in the cluster. And then, so when you use the Pixie UI and the CLI, it uses this in-memory data, and you can debug for something, like you can see your data for anything that happened within 24 hours usually. But if you want to hold on to this data in a more permanent way, you can do that with OTel.
Yeah, that is correct. Yeah, we use OTel just as the format of how we send that data out, just because, it's a common specification that people accept in other observability tools. And so it's just a nice way to be like, we're not going to build like a custom integrator into all these other tools that people have, but if it accepts open telemetry, then it works. And that's kind of the fun thing about CNCF and like all these open specifications is just like all these tools just hook together so well, and just like you can plug and play and just use whatever you want alongside with Pixie. And I think that's just something that's really powerful about the ecosystem.
I agree. It's really fun. It's like Lego blocks. It's like, it's great. So do you have anything else we need to cover about data and storage?
Something probably that is fun to dive into is just how Pixie, so it's like, since you have all this data stored in these individual nodes, when you query it, something has to figure out how to distribute those queries to all these different nodes in your cluster to gather that information. And so how Pixie works is that we have like this distributed query engine where we have something called a query broker. So when you make a request in the UI or the CLI, the query is compiled and the query broker figures out, okay, here are all the nodes I have available. Here's the information that I have on each of these nodes. Like it knows this node is running, this particular service on these pods. So if you're asking questions like, oh, can you find me all of the HTTP requests for this particular service, then it actually knows to send that query to those particular nodes, and then aggregate that information and send it back to you. So it has a very cool distributed query system that allows it to smartly hook into just like exactly which nodes it needs data from, and execute that and get that back to you, the user who's running the UI or the CLI.
So as a user, do I have any sense of this distributed query system, or I'm just presented with such a unified experience? I don't even have the sense that all this data is on all different nodes.
Yeah, I think it's more the latter, where it's like everything to you looks like a unified system, and Pixie does all of the magic and work of figuring out how to actually get that data to you. And it's really powerful because some people can have, massive clusters of thousands of nodes. And because Pixie is able to figure out, which nodes actually contain that data, then, you don't have to go and query all of those nodes for the data if you don't need to, and it figures that out.
Cool. Oh, we have a question from Pete World. Thanks for being here, Pete. This seems really cool and I want to dig into it. Any restrictions on the kinds of clusters where I can deploy Pixie? CPU architectures, OSEF?
Because we use eBPF with Pixie, really the only restriction that we see is just your kernel version. I think at this point, most people, when they're running their cluster, they're usually running a kernel version that supports eBPF. And so that's usually not a problem anymore. So Pixie works for the most standard cases. And so you can go ahead and just deploy Pixie to your cluster and just see what data it gets you. And if you do run into an issue, then that's something that we can help you figure out and try to support.
Cool. Thanks for that great question, Pete. The distributed query system, is there anything else I want to capture on the board besides what I've written here is data is distributed across the cluster, yet the user has a unified query experience?
I mean, I think that sums it up really well. It's just like the idea that Pixie is kind of doing this all under the hood for you without you having to worry about the fact that your cluster is thousands of nodes and that the data is actually stored, in small pieces across all those nodes.
Yeah, that's awesome. Cool. I'm so happy. This is very cool. This is really fun. Would you like to add, what else would you like to say about Pixie?
I guess the next part is just kind of the components like within Pixie. We've talked about a few already, like I mentioned, the data collector, but just kind of wanted to summarize all the different parts of Pixie that allow you to do all of this. So the biggest one is the Pixie Edge module, which is that data collector that we've already talked about a bunch. And then building off of the distributed query system, there's also, the query broker, which is the thing that goes and compiles your queries and figures out how to send it to all of the different nodes in your cluster. But it's larger, it's part of a larger component that is called Vizier. So this is the thing that actually gets deployed to your cluster itself. So Vizier consists of just a bunch of different Kubernetes services to help provide this experience of collecting the data and distributing the queries for the data and combining it with the Kubernetes metadata as in your cluster so that you can actually get more context about, the different things happening in your system. So it's like, rather than, this process made this network call, it's this pod that made this network call or this service that made that network call. So this is the part of Pixie that you deploy to your cluster in which to get that information.
So what's it called?
It's called Vizier.
VISIR?
VIZIER.
VIZIER. And Vizier is, will you give me a succinct definition I can write on the board?
It is the part of Pixie that is deployed to your cluster to help gather and distribute queries to your cluster.
Okay, so it's like underscores this part here.
Yeah. So it's basically the query system and plus the stuff that helps collect the Kubernetes metadata that we combine with your data, just so we're able to give you more context about the data that we're collecting. And so this is the part that, people actually deploy to each cluster that they want to add Pixie to.
Oh, that's actually makes me think of a good question, which is, does it work for multi-cluster setups?
Yes. So I was also about to just dive into the next part. So this is a great segue into that. But basically, Pixie, alongside with Vizier, which you deploy to each cluster, you also deploy a control plane. And so this is for just managing, if you have more than one cluster that you want to collect data from, this is a way to manage that and view that. This is the thing that hosts the UI and the API. And so you can, from there, say like, oh, I've deployed Pixie to 10 of my clusters, and you can dive in and, query from all those different clusters. We don't yet combine the data from multiple clusters because we do that distributed query system where, that distributed system is that cluster itself. So we don't combine, the data from cluster A to cluster B. So it's still like separate in that sense, but you kind of manage it from all like the same place.
Okay, I want to write that down, but I think I'm a little lost about, is Vizier a component in Pixie, or is it a whole separate thing?
It is a component within Pixie. So it's kind of the data collection part that is deployed to each of the clusters that you want to collect data from.
So the data, that's not the data, the edge module.
So
data
the edge
collector?
module is part of Vizier, actually. So whenever we say, deploy Pixie or Vizier to your system, it basically comes as a bunch of services plus that Pixie edge module, which is that daemon set.
So Pixie components, we have a Pixie edge module, which is the data collector. We have Vizier, which gathers and distributes queries, but it also uses the Pixie edge module to collect data.
Yeah, you just kind of think of it all as
this
package. Like Vizier is that whole thing.
Okay.
Like just think of it as a package of like, how do I start collecting data from Pixie and start being able to query it? Vizier is that package of like, this is what you need on your cluster. And then within Vizier is that Pixie Edge module. And we always kind of separate it just because, of how important it is, because that's the thing that's doing, most of the real work, which is the data collection in eBPF.
So all right, I think I understand enough, as much as I need to move forward. And so you were just going on about something else that that didn't kick in because I was too stuck on not understanding this. I'm sorry.
Oh,
so
no,
what
totally
were you saying?
So alongside that, and so you can kind of think of the Vizier and the PEM as the data plane of Pixie. So that's just the thing that collects data, runs queries on the data.
Okay.
And we also have what we call Pixie Cloud, which is the control plane. So that's just for managing the different clusters that you have connected with Pixie. This is the thing that allows you to create orgs in your system, or essentially create the idea of like teams. So you might have, one team in your company that has these clusters, another team that has another set. And so it's just like kind of the metadata level on top of Pixie that allows you to actually go ahead and use this in a way that works for your organization or your teams. So it's like, this is where you manage users. This is where you manage which clusters you have connected. And this is the thing that hosts the UI and the API.
Okay, so Vizier and PIM, which is Pixie Edge module, is the data plane of Pixie. Pixie Cloud is the control plane of Pixie. And then I would like to, you rattled off some things that it does, like, and I would like to capture some of those. Yeah.
So it's for managing orgs and users and clusters. So it's kind of the management layer of the data.
Okay. And this is where what you said before comes into play, where you can see multiple clusters from one control plane, but you can't see how those clusters are interacting with each other.
Yes, yeah, that's right. We don't combine the
Yeah.
data for multiple clusters together yet, but in the Pixie UI or the CLI, you can be like, run this query for this cluster, run this query for another cluster. And so you can kind of view them as separate blocks, and the control plane gives you a way to do that easily.
Cool. Excellent. I feel great about this so far. We're running out of space, but do you have some extra information? What's important to know still?
I would just highlight that the control plane, so Pixie Cloud, that part of Pixie is not, install Pixie in less than 5 minutes. It does take some work to go ahead and just like, manage your own control plane, because with that control plane, there's database management. Like, we need to have a database to store the different users in the system and things like that. And so it's like, this is something that we offer that you can just go ahead and self-host in Pixie. But there's a lot of people who also offer hosted versions of Pixie Cloud. And so it does make it easy for you to just install Pixie in less than 5 minutes on your cluster and get data without having to worry about the control plane side of things. And what I wanted to highlight there is that even in those cases, someone might be feeling uncomfortable about, somebody else using like an enterprise hosted control plane where it's running in someone else's system. But because the data that Pixie collects is so sensitive, we still have a bunch of things built into Pixie to make sure that your data is protected the entire time. So one thing that is also really cool about Pixie is that whenever you run a query in Pixie, that query is end-to-end encrypted. So, even if you were deploying Pixie and using someone else's Pixie Cloud to manage your cluster, there, like, even if somebody on that side were able to intercept the message to try to read your traffic or something like that and see, the data that Pixie is sending back to you as a response of your query, they're not going to be able to read it.
I have a question. So since you said this takes some time to set up and this happens immediately, does that mean this CLI and UI are different from this CLI and UI?
Those are the same CLI and UI. So the part of Pixie that takes less than 5 minutes to set up is deploying Vizier. And so that automatically starts collecting data, and you do that, once per every cluster that you want to start collecting data from. And then Pixie Cloud, the control plane, that is just deployed once in the entire time you're using Pixie, because everything else kind of hooks into that control plane.
Okay. Got it. So it starts collecting data within 5 minutes, but for you to be able to do like data exploration, that takes some more time to set up.
Yes, yeah. So that's why we kind of do recommend some people go and use a hosted solution for the control plane in order to start actually using Pixie right away. Because at the end of the day, that control plane, the layer on top, isn't really anything that does anything super special, right? It's just like user org level management that you see in a bunch of other tools beyond Pixie. So it's not like there's any special secret sauce in there. Everything that's special is what is really getting deployed as Vizier.
Cool. So we have one more little bit left. Is that what would you like to impart?
I kind of just wanted to talk through just like the process of the end-to-end encryption, because I think that's something that's really
Okay,
powerful. So just like going through the flow of what happens,
cool.
when you're making a request in the UI to, how that data gets to, or how that is queried from the PEM itself, and then how it gets back to you. So let's say that you are in the UI and you want to run a query to fetch, all of the HTTP requests that happened in the last 5 minutes on your cluster. So what happens to do the end-to-end
Uh-huh.
encryption is that in the browser, we will create a public and private key. And so the browser retains that private key. Only the browser itself knows what that private key
Hmm.
is, but it sends the public key alongside the query. And so when the query is made, that request is made to the API, which is the control plane, and it then basically sends a request to the Vizier that is running on your cluster that you're trying to query from. Um, the query broker,
Let's,
oh, yes, of course.
so the query is made, and then a public and private key is made on the browser,
Yes, yeah,
which is the UI.
yeah.
Okay. Uh, I'll write just private key. Although it's very hard yeah, that's all right. Private key is made by the browser. Okay. And then what's next?
All right. And then it will send the public key for that private key alongside the query that needs to be executed.
Okay.
And so that request makes its way to the query broker, which is part of Vizier running on your cluster.
Mm-hmm.
And the query broker is the thing that we talked about before, which figures out how to distribute that query to all of the different nodes in your cluster.
Ah. Query broker and Vizier receives query. And then the query broker distributes the query.
Mm-hmm.
So basically, the Vizier is going to send that query to every node, and then the one that actually has the right information is going to respond.
No, so the query broker actually has an idea of what kind of data is on each node. It knows that this particular node has this service running on it. And so if you run a query that just says, hey, give me all of the data, the network traffic for this service that I care about, it knows to only send it to the nodes that contain that data. And that is really useful because if you have a massive
Okay.
cluster, sending that query and asking, all those nodes to give you the data that it has, when, a large majority of them won't have any data pertaining to that query, then, you can skip that execution on
Ah.
those nodes.
Okay. So it efficiently knows just where exactly to send it.
Right. And then, so then once,
And
oh, yeah, go ahead.
I'm hoping there's only one step left.
Okay,
So let's
it's
do
almost
it.
done. So basically, once
Okay.
the PEM on that node receives the query, it executes the query, and it has the public key that was sent by the browser. It will encrypt that data
Uh-huh.
with that public key.
Ah. Okay. PEM receives query. Executes query. And then responds and encrypts with the with the public key.
Yeah.
Wow. I don't know what ANSI or IP. It's real dicey about whether that's going to be legible to people who look at the board later, but those of us in person, we understand. Excellent. That's super cool. I like how that works. So we can, oh, do you know what I would like to do is just put on the screen the docs of Pixie. And then is there anything else? Let's get that up. I can squeeze, is there anything else you want to say about Pixie that should go on the board?
No,
That
I
I
think
can squeeze in somewhere?
that basically covers Pixie, you know, kind of what it does, how it works, the different pieces that are involved in it. So I think that is a pretty good summary.
Excellent. And what I would like to ask, like for someone like Pete or anyone who watches this later who wants to try out Pixie or get involved in the community, where should they go next?
Yeah, so the docs that you just sent out are a perfect place for, you know, how do you get started with Pixie? It will give you all the different ways you can install Pixie and walk you through the data that Pixie collects. So if you just want to try out Pixie, go ahead, take a look at the docs, get Pixie deployed and just see what we can start doing for you. We also have a GitHub page, which is
awesome.
the place where you can go and take a look at the code and start contributing or, you know, posting issues on there, and we'll get back to you. So, you know, very standard way of just like interacting on GitHub, you know, pull requests, write issues. We also have a Slack channel, which is linked to in the docs, and you can go in there and just, you know, I'm on there, a bunch of other maintainers for Pixie and my colleagues are on there. And so feel free to come and ask any questions or see how you can get involved. We always love having people contribute to Pixie. And so it's always a lot of fun just interacting with the community.
We do have a question from Ravi. Ravi is wondering, is Pixie only for Kubernetes?
Yes, so Pixie is only for Kubernetes applications right now, although how Pixie works is, you know, since we just use eBPF at the end of the day, there is nothing about how it works that is really unique to Kubernetes, but we do want to, in order to just provide you a good experience where, you know, we're combining Pixie data with Kubernetes data, we do just say that Pixie is for Kubernetes, but we do hear a lot of responses of people who just want to deploy Pixie to, like, you know, some bare metal machine that's not running on Kubernetes. And so that's something that we are thinking about adding support for. I think at the end of the day, in order to deploy Pixie, you probably will always need a Kubernetes cluster just to deploy, you know, the things like the query broker, for example, because that's just a really nice way for us to easily package things up into services and pods that need to run on your cluster. But the individual nodes that we talk about, those may not necessarily have to be part of a Kubernetes cluster.
So you could just spin up like a really lightweight client cluster on your local machine and use it to deploy Pixie.
Yeah, and then
is that what
like
you're
I
saying?
said, this is not supported yet, but you know, in the future, you may be able to add nodes that are not part of your Kubernetes cluster. But yes, you do always need like some form of Kubernetes cluster running just to have, like, you know, the query broker up and running, for example.
I've seen that pattern before. So what I would like to do to close this out, I would like to recap everything we've talked about and verify our knowledge. And meanwhile, this is also, for those of you watching, a great time to ask any more questions if you have any left. So please don't be shy. So we started by talking about the world before Pixie. And basically, it's the problem of observability. Understanding distributed microservices is really hard with the wild amount of complexity we have. But then it's also very tedious to instrument all of your applications to be able to capture observability information. So that's where Pixie really helps. So Pixie is an observability tool that helps you collect a lot of information about your application without adding any instrumentation to the app itself. Did I spell observability wrong? I think I did. So the first question I asked, like, what do you mean by lots of information? So we got more specific about what that is. So lots of information still is like includes resource metrics like memory and CPU. It includes network metrics like bytes received from a pod. And it also includes protocol tracing. So this is not distributed tracing, but protocol tracing, what it is it traces the messages between the pods for various protocols. And example protocols were HTTP, HTTPS, like database calls and Kafka messages, for example. And then lots of information also includes app CPU profiles, which you can figure out how applications spend their time. What are they doing with their time? So that is awesome. And one question I asked at that time too is like, is this meant to be instead of or in addition to traditional application tooling? And you said ultimately you recommend having both, correct?
Yes, that is right. Yeah, Pixie should be used in conjunction with other tools to give you the most visibility into your system. Just because Pixie cannot figure out, very application specific details for you.
Yeah. What's something that Pixie can figure out that traditional observability instrumentation cannot figure out?
I think it is, you might be able to collect the same information from protocol tracing if you go and instrument it yourself. But I think because of the sheer amount of like protocols and network traffic, it can be a lot of work to do, and isn't able to collect you things like the full HTTP request and response bodies. So things like that, I think Pixie is really able to provide for you.
Cool. So then we talked about the user experience with Pixie. So getting started, you can install it and it takes less than 5 minutes to get started, and it's already collecting data pretty immediately. And when we said collecting data, it collects by default literally everything it can, although there are ways to have it collect less data because it is a lot of information. Then it takes a little bit of time, but you can set up a CLI and API, the UI, some dashboards to be able to access your data. If you access it via the CLI, you use a Python-like query language. And then it seems pretty magical that you could set it up so easily and get so much information so quickly. And part of what makes that magic happen is the eBPF. So Pixie's eBPF based, and eBPF allows Pixie to hook into the Linux kernel in a safe and a performant way. So Pixie is going on any given compute node, Pixie will use 2% or less, probably less. And then Pixie is powerful and can even collect encrypted data. So it also gets full requests and responses. So we talk a little bit about how to keep that data, since it can collect sensitive data, how we keep it safe. So then we get into data and storage. Well, first of all, is there anything you'd like to add at this point, Michelle?
No, I think that sounds pretty good. That's a good summary so far.
Okay, great. So then we got into data and storage. So Pixie collects a tremendous amount of data, although you could choose to have it collect less. And then Pixie has a data collector that we learn later is called the Pixie Edge module, or PEM, you would call it. So it's deployed as a daemon set. It collects data and then it holds that data in memory. And that's how the sensitive data we talked about before is kept in cluster. So Pixie CLI and UI that we talked about before, that uses this in-cluster memory that's distributed across the cluster. And this data is usually saved for about 24 hours. So Pixie's meant to do like real-time debugging. But if you do want to save this data, and again, it's a lot of data, but if you do want to save it, you can use open telemetry to export the data to a more permanent place somewhere else. And then because all the data is across the cluster, you could have thousands of nodes in your cluster, and then Pixie is collecting data and storing that data on each node in the cluster. Even though the data itself is distributed across the whole cluster, the user experience is unified. You're seeing it from the dashboard or querying it from the CLI in a way that the fact that it's distributed is visible to you as a user. So we talked about Pixie components. So the Pixie Edge module is the data collector we already talked about, and then Vizier is a bigger component that has the Pixie Edge module as part of it. So Vizier is the part of Pixie that gathers and distributes queries, and it has the Edge monitor, so it's also collecting information. So Vizier and Pixie Edge module, or PEM, are basically the data plane of Pixie.
Yes.
And then Pixie Cloud is the control plane of Pixie. So this is where we're talking about, again, the CLI and the UI. So with the Pixie Cloud, that's where you can manage orgs, you can manage users, you can manage clusters. You can see and manage multiple clusters, but you can't yet see how data interacts between clusters. All the data itself is localized to clusters. And then this, unlike the 5-minute experience, this takes a little more time to set up, of course, because you're configuring it for your own particular organization or the experience you want to have through your UI. It's up to you who has access to what, I imagine.
Yes, yes.
So the last thing we talked about then is queries in Pixie and how they're encrypted end to end. So a query is made, and then the private key is made by the browser alongside the query. So the public key is sent alongside the query, and then the query broker in Vizier receives the query. I misspelled Vizier here, but that's okay. So Vizier receives the query, and in receiving that query also receives the public key. And then the query broker distributes that query to only the node that needs it. It knows which node has the pertinent information, and it sends the query to that node. And again, the public key is alongside of it. And then the Pixie Edge module on the node itself receives the query, executes the query, and sends a response. But since that public key is a part of it, it encrypts the response using that public key. And that's how queries in Pixie are encrypted end to end. Is that correct?
Sounds perfect.
Okay, cool. There's some very Cliff Notes writing on that. So I would like to get it correct with my voice. Great. I think that's a wrap. Is there anything else you'd like to add?
No, I think that covers all of it, but I just wanted to thank everybody for tuning in and just learning about Pixie and how it works. I think this is a project that we're still very actively working on, so stay tuned for more updates and features. I think we already heard some on the call, things like being able to support nodes that aren't part of a Kubernetes cluster, things like that. So we're definitely actively want to work on it, and just excited to see where the project continues going.
This is awesome. Pixie's a super cool tool, and I really enjoyed how it didn't fit in the paradigm of anything I knew. It's something completely new, which is so fun. And we have a lovely last comment of thank you for the show. I love so much this board game. Thank you. That's so nice. How I end these shows, Michelle, is I play the music again and dance a little bit. If you feel like shaking your shoulders, you can, but if you don't, it's okay. So goodbye, everyone. Thanks for a happy and lovely chat. Thanks, Michelle, for sharing your expertise and time with us. I appreciate you. And thanks to everyone who watches the recording too.